Let me start with a little bit of recapitulation on what was covered yesterday. We started with mild steel, saying the advantage of mild steel being its strength, has the highest tensile and yield strength. All load bearing designs must be made with this. Next I talked about thinness. Thin sections can always be made with mild steel, as are used for portable equipment. Portable equipment need to be light. The moment they are light, the thickness needs to be small, because for a given what you call volume, steel is still heavier. What is somehow a little problem is that corrosion resistance is not very good in the case of mild steel. Rusts easily and does not have any corrosion resistance. Protective electroplating is carried with zinc, cadmium, nickel and chrome. Nickel and chrome give it a very attractive finish, and often MS is chosen so that nickel plating can easily be used as a decorative finish. This I had given you an example of car bumpers and so on, saying earliest they were made with mild steel, and then as the thickness can be made smaller, light weight also can be reduced, and then everything is chromed. So even today, except for some high performance bicycles, bicycle rims, motorbike rims, all those continue to be made of steel. So the word mild is a what you call not a very good word to say, but still because of the small traces of other materials compared to pure iron sheet and compared to very high carbon steels, it is called mild steel because of the composition. Main problem with this, as I have told you, being that we have this problem of corrosion. So nickel, chrome, all this is done. Then we have the manufacturability. Typical fabrication process involve machining operations, press work, and various type of things called nibbling, joggling, embossing and ribbing or whatever you call it, that has come very well because of the mild steel ease of fabrication, and peculiarly it is relatively ductile. It is not a brittle material, it does not break that easily, and various types of heat treatment is possible to make it such that there is more elongation is possible, or what is called annealing can be done easily. After you anneal it, even work related process related hardening can easily be overcome. So if you were to take your own tumblers, over here we call it a steel glass. It looks like oxymoron. How can it be steel and how can we call it a glass? Earlier it used to be a water pitcher, and eventually it became a small tumbler, but then you do not tumble it also, but you just carry the so called steel glass. It is made of a variant of steel which has that what do you call shine, white color. What you would have noticed that generally they are deep, conical with a small taper. Occasionally the new process make them really practically without any taper. All of it is done by drying or pushing the material out, which is called deeper drying. Deep drying, if you take a small eating plate, probably it is just standard drying procedure, then you do a bit of trimming. Why I am insisting on this is such things continue, that application of that is very much important in our electronics also. We need to make deep objects. So the advantage here is press work. Something related to this, press work is all very well established. Theory and practice of metal working is there all the time. You can know how to calculate a punch load, you can calculate press load, you can find out what is the particular condition of the material that can be used for operation is possible. Similarly, tooling in the form of dies and punches, progressive tools, stress relieving after deep drying, which I spoke to you, are all fairly routine. A lot of it has evolved after people have observed the consequences of a previous operation. If you try to bend something repeatedly, it has a tendency to break. Can you overcome it? That is how a lot of these things have come about. A theory explains a physical phenomena and certain conditions can be optimized, saying using a particular bend radius, what is it that we can achieve? And it is not the other. The equation does not determine the physical process in nature, because several of the parameters which are used in the processing are not known. So, we may have a little problem on how to test whether you have learned something here. It is not easy. Testability is not easy, because it were remembering a lot of these and reproducing, that does not take us anywhere. However, if I ask you a sample saying now go around and kindly collect a sample and I want you in your hand, most likely that is a ultimate test that you have taken the trouble of collecting it, and you have not jumped the queue by buying a kit where already it is labelled and you peel it off and show, sir, this is called a 2-stage deep drying thing, you see in the corner flash has been removed by punching and all that. It is read from a cue card. So, we still have this problem of how do you understand the process and then how do you implement it. That is the reason even the latest software tools talk about make a test piece, find out what are the various allowances to be given and include it in your calculations. So, I will get back to the slide here. Tooling in the form of dies and punches, progressive tools, stress relieving after deep drying are routine. Joining is easily done by common welding techniques including arc and gas welding. So, we are all familiar with that welding where that sparks fly. So, probably it started with the earliest wrought iron. Eventually, now we have electrical welding of one sort or the other. So much so that we take it for granted. And in fact, when materials joined by any of these welding techniques rarely fail at the weld, they fail somewhere else or other operations related to welding. Size and shape of the parts are no constraint. Very large parts can be done. Small parts like link levers, support bracket and such are easily fabricated using blanking. Large parts like door and panels of racks used in process control equipment installations which are not handled frequently are still made of mild steel. Tool making has been optimized that most piercing punches, folding die sets and press brake tools are available. You need not go about designing one more. In fact, if you go to the manufacturer's catalog of any of the punch equipment, you will see these so-called prefabricated punches, dies of various openings, everything is available. You need not go around and try to make it. Tooling costs as such are considered low. You can go to any person who does this fabrication for you, and depending on their load they can accommodate you. Mild steel is the cheapest metal that can be used in electronics. Cent is used as a preference for all low cost design. Inverters, UPS, voltage stabilizers, most electrical switchgear, and most important, it is highly recyclable. So, in case something is a problem, you just strip the whole thing and then you can give it back for disposal, safe disposal. Unlike your other materials, it is not so bad. And mild steel of different grades is easily available. Besides several gauges of sheet, cold roll sections like channels, angles, tees are supplied in small lots. You just need to go to the store and buy them. There are huge pipeline inventories, and procurement of special items is not very difficult. Pipeline inventories means something from the original manufacturing place and all the way to the your last retail. Lot of stuff is stored in different places and all. Now in case something is there in the catalog, if you are ready to wait, you can eventually get it. You have other things like perforated sheets, expanded meshes, weld and chain link meshes are common. Speaker grills, anti-pop filters for microphones are all examples. You have them everywhere. So it is real. Yesterday I showed you the example of this wireless set. You remember? It's again a steel item. This clip here on this is a steel item. Weight, MS is heavy in comparison, hence it is avoided in portable or lightweight. A cover for a PC in the baby 80 form will weigh at least a kilogram. A thinner sheet may need additional stiffness. So depending on the application, for most stationary applications, steel is used despite its weight. Appearance, raw MS cannot be used in the original form since it has to be plated. Steel is chosen as a base material where chrome or nickel. Steel does not have any inherent structure, however it can be brushed to get a special look. It is etched or embossed to give special textures. Sand and shot blasting, that is, you take a sheet and then you direct some grit through a air or some other medium. Any special texture you want can be made. You would have seen the tread steps that you see across. Sometimes if you have a internal staircase, you get the tread sheets with 4x4 embossing and all of it. That whole thing in the rolling operation itself, somebody does the dents are created and then it is ready for you. And some of you must be familiar with structural rods which are called torch steel. Somebody long ago took a patent, actually did a lot of thing, and lot of observation and analysis where analysis and observation go together. Why is RCC failing? RCC often fails because the core reinforcement appears to move, and the moment it moves, game is lost. So to prevent it from moving, they started putting all sorts of features on it, which is part of the manufacturing process. So eventually, now in fact to get a smooth rod is difficult. Most places you only get the tough, highest quality steel with the highest yield strength, but with the torch steel sections. Extending the thing to our application, in case you want to have a textured surface, it is possible to make textured surfaces, not impossible to make them. Steel does not have any structure, it is etched or embossed to give special texture. Sand and shot blasting is used rarely to give that special texture. Steel can be painted well after some treatment like galvanizing, zinc plating or phosphate conversion. It is primed with red oxide and painted. Highly attractive colors as seen in automobiles on non-reflective surfaces as in front panels can be achieved easily in steel. Quite easily we can get this. Then finally we have this pre-plated steel. So pre-plated steel has the various advantages. So even normally because of susceptibility of corrosion, they probably some oil gets either coated or it is sprayed, it comes. But still chances are occasionally you find them damaged. So tinned and galvanized sheets are also supplied. I was making a reference to your car door yesterday. All car doors mostly are all embossed from pre-galvanized sheet. Galvanizing is nothing but dipping it in zinc, otherwise they are all zinc plated directly. So electroplating is called electrozinc. Dipping in a hot bath is called galvanizing. The base material is usually mild steel, and then what is coated on top of it is zinc. So, in case I have done a mistake on the nomenclature, kindly giving me a feedback does not help. You can also give me a feedback, but go and check it out yourself by checking on the actual sections, asking somebody what is it like that. Reading will take you near there around 90%, and the last 100% is about your physically checking the particular thing. So, a smooth zinc plated steel, you can feel it, it is smooth. But a galvanized sheet has, you can see one crystalline structure on it. So, GI sheet has a crystalline structure. Now, if you see the wire which use the steel iron wire, invariably it is galvanized iron or variants of it. So, it is a very good process. Tin sheets are used in can making and an item like containers for EMI prone circuits, RFI filters. Galvanizing is use of hot melt zinc in coating steel. Large items and panels are made with GI sheets, galvanized iron, more economical than plating after fabrication. Fixed structures like racks and consoles are even spray galvanized. So, while I am not familiar with it, I expect that there is a hot melt some device which will directly start spraying things on that. Maybe instead of directing it like that, maybe it goes here and then the thing gets coated. Steel is magnetic and is used for its very effective EMI suppression. Depending on the thickness, EMC control is possible, electromagnetic interference and control for it. So, the openings inside is a very critical thing. By some, I feel physics of, laws of physics, miraculously any opening which is less than 2.5 millimeters, that is small punched sheet with 2.5 millimeters opening, generally keeps out all radiation. I think there is a 30 megahertz limit. So, things which between say 30 kilohertz to 300 kilohertz to 30 megahertz, this acts like an effective shield. Instantly that same 2.5 mm is used in your IP specification. I do not know what came first, whether the openings became this much or 30 megahertz was a critical thing or IP came first, but all of them are nicely integrated and made for each other thing. So, that if you have a perforated sheet which has 2.5 mm small openings, you can safely use it, and most RF applications of the lower frequency take up to 30 megahertz, which is considered the old standard for the RF equipment. Next I come to aluminum. At this point, while that first part of it I have read along with you, this is available in both the formats. We have a recording here, then I have a PowerPoint presentation, then I have text which I have written up. So, I expect that all of them will be available to you, but with that usual watermark feature. So, you can read it for yourself. Second most common material used in electronic enclosures, aluminum. Aluminum has only a third of the yield strength of steel. However, in several applications, gross strength of the material is not the prime consideration. Strength to weight ratio is higher than steel. Critically designed components in steel cannot be substituted by aluminum. It is reality. If something has been made such that only a steel structure can hold it, just like that, substituting one for the other does not help. I have given you already the example of your bicycle frame. If you have the basic trapezoidal bicycle frame, I hope you remember trapezoidal, I will just write it in the space that is available here. So, I have slowly my bicycle is getting ready. So, triangle here and a near triangle here. The way this whole thing has been optimized, if you just blindly I won't say blindly, without due consideration for all the other operations, if you just replace this trapezoidal frame with aluminum, you may end up with problems. It is not stiff enough, and we have other problems depending, unless the grade is very critical, and automatic replacement is not possible. New components can be made if the design starts with aluminum. A slight increase in the thickness corresponding to steel and additional ribbing can be added to make overall lighter. Special grades called the 5000, 6000 and 7000 have been developed, which are used in the aerospace. Spin-off from this are used in high-end commercial equipment like cameras, video and scientific equipment. In India, only some of the grades with silicon and magnesium are available in the construction industry. Profiles, sections, extrusions for racks and cabinets, all these are made with aluminum. So, at this point I will see whether I can go to a rack which are likely to find anywhere. I have just randomly taken it from the internet, but you see here these vertical members are there. Depending on the design, it is possible for us to make it out of either aluminum or steel. Originally, the load bearing things, all these vertical items used to be once upon a time made in steel, but right now all of them have been replaced with aluminum extrusions. This picture is quite the same as what you had in the other picture. Now, you see here we have a beautiful place for a monitor, then you have a place here for a keyboard, and since this is a little familiar with you, then there is a utility drawer, and then we can make this whole thing. Most of the load bearing things in this case are made with aluminum, except a few things like this drawer and there is some fixed shelves and all that. Everything else comes with the perforated section. Probably this is the vertical section which you find. So, some of them have been made with mild steel. Mild steel, punching these things is very easy. Now, they have been able to substitute this with aluminum also. Instead of having a separate piece like this, they are able to make start the design with aluminum, and then you can optimize these things. Main thing about aluminum is it has an inherent corrosion resistance. Exposed parts will not corrode, but may form patches from atmospheric contaminants. To avoid patches, bichromate passivation is employed. So, potassium bichromate solution is made, and something is done, and this is dipped in it and taken out. Anodized parts are stable and common. That is, anodic layer is nothing but an aluminum oxide layer. Conventional electroplating makes the part or our job as the cathode, but in the case of this thing, the anode, this forms the anode, and then some material gets carried away and oxidation takes place, and then they seal it and all that. The advantage in the end is that you have a very stable inert layer on the top, which is good. That is what we are looking for. Enamel painting after etching and powder coating can be given. So, the moment you have this powder coating, you have an advantage, especially of powder coating, because the skin that is formed by that powder after baking, it is generally very impervious to outside contaminants, and inherently it has a pleasant appearance, non-reflective or reflection can be controlled, any color of your choice. So, these days various furniture items and all that, they do not use plating anymore, and plating involves still some chemicals which are not easy to dispose of. And in the case of powder coating, I think except for maybe degreasing and washing and little bit of solvents, it is probably a little more what do you call environmentally friendly. So, I am no expert on it, correct me if thing easiest, as I have told you, 90% you can learn by looking at books and all that, last 10% to go to premises and check. Aluminum manufacture uses the same basic tools for sheet metal operations. Load and tonnage requirements are lower for presswork. Special composition alloys have problems in forming and may show cracks. So, if something is made so that it is strong and also it is tempered during heat treatment, naturally it will become brittle. So, there are various tests that can be done, and it is possible for us to make or accommodate design upfront for these things. Mishandling on the shop floor leads to accident tool marks. Items like profiles and flats are easily machinable. Composition has to be verified. Softer alloys are considered a nuisance for machining due to their high ductility and poor chip forming characteristics during milling. Machining is not easy, though it looks like you have a nice machine and you load the job and everything comes out. A lot of practical considerations are there. The only safe good material as of now is still brass. Inherently brass is a chips form, they break easily, and then nice finish can be obtained, and then over brass you can plate most of them and it is good, but ridiculously expensive and not strong enough for us.